Hello and welcome to part B of chapter 3. So today we're going to talk about prevalence. We're going to show you how to calculate prevalence. We will explicitly discuss what goes in the numerator and the denominator. We're going to discuss about the difference between incidence and prevalence because there is a huge difference between the two, okay? And of course, we will always finish our lecture by discussing the limitations when it comes to defining the numerator and denominator for prevalence measures. So in the previous lecture, we talked about incidence rates or identifying new cases of disease. The question is whether that is always possible. What do you think? With infectious diseases, a person goes from a healthy state to a disease state fairly quickly. Thus, we can identify or approximate the onset of the disease. But how about diseases that take years to show any symptoms? For example, several types of cancer may take up to 10 years to show any symptoms. Furthermore, people who have annual checkups are more likely they will be able to identify they are affected by a disease, although we don't always check every part of the body. In this diagram, you can see we have a defined population at the baseline. Okay, and we can determine who has the disease and who does not have the disease. If we follow them over time, the same cohort, we can continue to monitor their progress. Your medical files that the doctor keeps provide such surveillance. When we calculate attack rates, we place the people who developed the disease in the numerator and all the people who were at risk of being exposed to the same food in the denominator. Attack rates do not specify a time interval, but for many foodborne illnesses, we know that they happen a fairly short period of time. Attack rates are not true rates since they do not incorporate time in their denominator, but they are proportions, meaning out of the whole people who ate a particular food item, how many became sick. Prevalence is different than incidence and provides a snapshot of the population at a point in time at which we identify who has and who does not have the disease. Prevalence takes into account all existing cases of disease. Existing is a key word here that I want you to remember. Incidence deals with new cases of disease only while prevalence deals with existing cases of disease. For example, the city of Philadelphia has 7,000 people with arthritis on January 1st, 2015, which means that we do not know when the diagnosis took place or when the disease started to the affected individuals. We simply know that at this point in time, 7,000 people in Fullerton have arthritis. If we know the total population of Fullerton, which we do, we can then calculate prevalence and we will see that on January 1st, 5% per 100 persons were affected by arthritis in Fullerton. So this is the equation for prevalence. On the numerator, you will see we have the number of people who have the disease at a specified time. And the denominator, we have the number of people in the population at the specified time. Notice that the denominator does not state to include only people who are at risk, like we did with the incidence. Also notice that we always multiply our answers with a base to make sense, and we state our findings using that base. For your example and your homework assignments, I will always tell you what base to use, but know that we usually select a base based on the total population in mind, okay? The larger the population, the larger the base will be. So here's a question for you to think. What would be the denominator when calculating the prevalence of pregnancy among women in North Carolina? Shall we include all women in North Carolina, regardless of their ability to become pregnant, or shall we include the total population? Well, since we're trying to calculate pregnancy prevalence among women in North Carolina, it would only make sense to include women who are able to become pregnant. Men do not belong in this calculation, neither young girls or older females. Prevalence as a measure can tell us rather, anything about the cause or etiology of disease. We do not know the onset of disease like we did with incidence, so we cannot identify the cause. How long a particular disease lasts will affect our prevalence. You can see that by examining the equation shown on the bottom, which states the prevalence is equal to the incidence rate times duration. The longer the duration, the higher the prevalence. So how do we figure out the duration of the disease when we know the incidence rate and the prevalence? Well, based on the P equals IR times D equation, you can divide the prevalence with the incidence rate and then you get the duration, just like on the example shown here. So you have lung cancer incidence rate of 45.9 per 100,000 person years. Prevalence of lung cancer is equal to 23 per 100,000 person years. Thus, the duration would be prevalence divided by incidence rate, right, which is equal to 23 person 100 person years divided by the 45 right here, 0.9 per 100,000 person years, which is equal to 0.5 years. Okay, so individuals with lung cancer survive 6 months from diagnosis to death, okay, which is very, very short. Uses of prevalence. Okay, so how do we use prevalence in public health? We use it mainly for planning and administrative purposes. For example, we know that cigarette smoking contributes greatly to both lung cancer and cardiovascular disease. You have witnessed the past 10 years expansive campaigns aiming to educate people and discourage them from smoking. Legislation-wise, in most states, it is not allowed to smoke in most public spaces, and heavy taxes on cigarettes impacted those who smoke, and many quit because of it. Also, researchers always look to develop cures or interventions to help those affected with a disease. The NIH funds research projects that would positively impact health issues with a high prevalence. It is in everyone's best interest to check the prevalence rates and prioritize accordingly. Since people move, people's disease states changes. Time is an important part of calculating prevalence. Meanwhile, it is impossible to survey entire cities in a day to calculate prevalence. Therefore, in reality, the survey takes much longer. When you solve for prevalence, you will see that I state in the description at mid-year, which essentially implies at a specific point in time. In this example, we survey students on a specific day and we are trying to identify how many have a cold. We do not ask them when they first develop symptoms, but we ask them if they have cold, yes or no. Based on their answers, you can see from the calculation that 26.6 per 1,000 students are affected by the common cold on September 1st of 2011. There are two types of prevalence, point and period prevalence. Point prevalence entails looking at a specific point in time and examining how many people affected, although not entirely feasible as we previously stated. Period, on the other hand, looks at how many people have had the disease at any point during a certain period. That can be a 2-year period or a 5-year period. The difference between the two would also be on the way you would ask the question whether a person has the disease or not. For example, for point prevalence, you would ask, do you currently have a cold? While for period prevalence, you would ask, have you gotten a cold in the past 3 years? Again, for those of you who love to organize their notes in table format, here's the main difference again between point and period prevalence. Now look at those two fractions and tell me which one is of greater concern. You may be tempted to say the 10 cases of rabies per 200,000 persons in Alabama County, North Carolina, but the truth is the above information does not provide you enough specific information to describe anything. Here's another example of prevalence and how we can interpret our findings. We have 500 men with lung cancer. We ask them about their smoking habits. We know that 461 men smoked, which is greater than 1 pack per day. Okay, so when you calculate the prevalence, would be 461 men who are the smokers, right, over 500 men with lung cancer. That gives you 0.922. So how do we interpret that? Prevalence of smoking among these 500 men with lung cancer is 92.2%. Here I'm iterating the differences of incidence and prevalence. The main idea is that prevalence is not a measure of risk since we do know nothing about the onset of disease of the duration. Okay, so a lot of you might be tempted to confuse incidence and prevalence. Just remember that incidence deals always with new cases of disease. Prevalence takes into account existing cases of disease. So since those cases may be existing for 5, 10, 15, possibly even 20, 30 years, right? There's no way we can possibly know what caused the disease. For example, an individual with cancer, right? Maybe he has lung cancer, right? But he can be a smoker, but also he may also worked in a factory where he was exposed to a lot of toxins. Well, the question is it the cigarettes that caused the lung cancer or was it the toxin in his work? You really do not know unless you actually follow people over time and you can actually control the exposures that they have. Hence, when somebody has a diagnosis for a very long period of time, it's very hard to pinpoint what caused the problem. Take cardiovascular disease, right? How many causal factors do we know? Lifestyle, stress, diet, uh, sedentary lifestyle. So there's so many different factors, right, that can actually cause cardiovascular disease. Even family history plays a role. So how can you identify who actually got cardiovascular disease because of lifestyle factors, because of smoking, or because of family history? Because sometimes you may have family history, but at the same time, if the individual also engages on risky behaviors, that would elevate his risk even more. But if that person has a diagnosis for, and he's maintaining through medication for 5, 10 years, and if he's also eating unhealthy and he's smoking and he's exposed to toxins, which one is to blame? We really do not know. Okay, so etiology is not something that we can really point our finger with prevalence, okay, as we did with incidence, okay, because incidences are new cases of disease and it's much easier to, I guess, identify the cause if you may. Now, this is a great example of when prevalence is the best tool to look at when you want to examine trends. Asthma is a disease that affects many young children, and it is very difficult to pinpoint the exact onset of disease. This figure shows current asthma prevalence in children up to 17 years of age by state between 2001 and 2005 in the US. The map was created using GIS and the inputting the prevalence rates calculated by asking participants 2 questions. Has a doctor or a health professional ever told you that your child has asthma? And does your child still has asthma? We can see that the darker the color indicates the higher prevalence. Thus, northeastern states tend to be more impacted with childhood asthma cases. Climate and pollution plays a big role in asthma, so that alone can explain some of the reasons why it is higher on those regions. A more detailed interview of participants can reveal further information that can explain the difference. Poverty is another factor that influences asthma, and there's a large number of Puerto Rican kids on those areas, so that would be another reason explaining the differences between the northern states and, for example, even California. This is an interesting figure. Look at the difference in obesity prevalence in the US over time. The map in 2010 tells a story that is where we headed unless we do something about it as a country. Look how in 1990 you can see we even had light blue. Look at California, right? So this is like um, less than 10% of obesity rates. And in fact, I remember when I moved into the US, we used to be one of the leanest states, if you may. You can see in the South, they were a little bit higher, 10 to 14%, but nothing like 2010. On the South, you can see it's greater than 30% of the population is obese, and California has turned yellow. That means 20 to 24% of our population is actually obese. So we went from being the leanest state, okay, to actually having an obesity problem. As you probably already figured it out, in epidemiology, the toughest thing is to identify who goes on the numerator and who goes in the denominator. For prevalence, the concern is the numerator, and we will explain why. Let's take rheumatoid arthritis, for example, which is a very difficult disease to diagnose. Doctors, in order to diagnose the disease, use various criteria. The question is, what happens when the criteria used are not the same across the board? The figure shows the difference in prevalence calculated in Sudbury, Massachusetts in 1964 for rheumatoid arthritis using two different sets of criteria. And here you can see the difference between the two, right? So you have the males and females. So this is one set of criteria, right? Here for the males, and this is for the females. So depending the type of criteria they use, there's a huge difference on calculating prevalence of the problem. For the denominator, the main concern is consistency in how we classify people, and unique circumstances such as women who had hysterectomies do not belong in the denominator for uterine cancer, since they no longer have a uterine in order for them to even get cancer. And that is it for today. I think this was a short, easy lecture. But again, if you have questions, reach out to me. Have a good one.